Okay, so Mike. Mike is my brother, and he was a camp counselor years ago. How many years ago?
I was thinking 3 summers, but more years ago than that.
Right. You were there for 3 summers. Okay. So Mike, tell us a little bit about what kind of science you do and what we're going to do today.
Okay. I am a chemistry professor, which means that I teach chemistry to college students. And chemistry is just one type of science. There are lots of different types of science. So you may be familiar with like biology, which is the study of life. Or you may have heard of like physics before, which is how things like move around and how electricity works and how energy moves. Or we have like earth sciences, which is extra relevant out at camp when we try to understand like how mountains form and what rocks are made of and that sort of thing. But I'm a chemist, and a chemist, the study of chemistry, is trying to understand how the little tiny things that make up everything around us, so atoms and molecules that make up things like this piece of glass or my t-shirt or even my hair or my skin, are made up of small little things called atoms and molecules, and I study how those things interact with each other. So often we use the word chemical in a sort of negative way. We kind of use it to mean like that dirty, scary stuff over there. But one of the things I try to teach is that chemicals are everything around us. Everything is made up of chemicals. So just because something's a chemical doesn't make it bad or scary. It's just how we use it and how much of it we may be around, or certain kinds may be more dangerous than others. And so we try to understand that. That's one of my jobs as a chemist. And so today, what I thought we would do is I have prepared 3 different experiments for us to do, depending on if we have time to do them all, that all use chemicals that are in some way or another interact or related to things that you might have around your house or might be related to different things. And the theme throughout all of these 3 experiments today is going to be cleaning, because we're so into cleaning right now. Your parents may be really into cleaning, trying to keep you safe or trying to keep them safe. And so I thought we would kind of talk about what cleaning is and how there are different ways that we can clean stuff. So the first experiment is going to be one that maybe, Beth, I can send you a link and you might want to share with people. It's something that you could do safely at home later if your parents tell you it's okay. The other 2 are not going to be ones you can do safely at home. This is just stuff that I have supplies to do. So pay attention in the first one. If you think it's cool, you might be able to get some instructions if your parents are willing to let you try it at home by yourself. The other 2 are just going to kind of be watching. But I will admit, I have this small little camera that I'm working with. I'm going to move it around to try to give you a good perspective. So if you can't see stuff, you need to let me know. I have my audio on so I can hear you when you talk to me, and I'll try to ask you some questions about what we should do next or what color should we try, and you just let me know and I'll see if I can do what you want to do. Does that sound good to everybody? One of the important things whenever you're doing anything with science is you always have to be safe. So I've already got gloves on to keep my hands safe, and I'm going to put my safety goggles on to keep my eyes safe, because one of these might go poof a little bit. So the first thing I want to talk about is something that's probably pretty boring seeming, but is really important right now, and that's soap. We use soap all the time, but have you ever thought about what soap actually does? So if we were to try to think about everything around us and just classify them into sort of 2 big groups in terms of chemicals, those 2 groups would be things that wash away in just water and things that require soap to be washed away in water. So 2 big different classes of kinds of chemicals. This is really important right now when people are really worried about the COVID-19, the virus that everybody's talking about, because if you get virus particles on your hands, they probably won't wash off with just water. So what we have to do is always use like hand soap and wash our hands for like, I think they say 20 seconds is good to do. And that's because if you just use water, the virus proteins, which is a component of the virus, or the virus lipids, which are a component of the virus, stick to your hands. You have to use some sort of soap. So I thought we would look at that today with another thing that you have probably around, which is milk. So if you want to try this experiment at home, you can't just use any milk. You actually have to use whole milk for this to work, or something like cream or half and half, but whole milk is cheaper. So the reason we have to use whole milk is because when you go from like whole milk to skim milk, some people like skim milk, because what they do when they go from whole milk to skim milk is you take away a lot of the fat that's in there. And what this experiment is going to do is show us how when you have fat in something, what soap does is help break that up and sort of contain it so that it can get washed away with water. All right, so I'm going to grab the camera. You're going to have to let me know if you can see stuff here. So I've prepared for us, this is called a Petri dish. It's just a small container of milk. So I'm doing my best here. All right, so this is just milk. This is just that whole milk. And I'm gonna put some color in there. What color should I put in there? I have green and red and blue.
Blue.
Blue, okay.
Blue.
All right, so let's put a couple of drops of blue. Maybe we'll put some red in there just to have another color. Does that sound good? I'm a little partial to red because my last name has red in it.
Okay.
And what you may notice as we're just looking here, this dye doesn't move around very much, right? The milk is very still. The dye stays very still. I'm going to take this container full of dish soap and get this glass rod and put some soap on the end of it. And when I put it in the milk, let's see what happens.
Spreads apart.
Yeah, it spreads apart real fast.
Before.
Not moving at all, just sort of spreading like crazy. Give it a second. Normally, it'll start like spiraling and really going crazy. If I can get it to go.
Oh, very.
And we can make some really cool shapes and designs in here just by moving the soap around. So what's happening is that soap is seeing different molecules in the milk called proteins and lipids, and the soap is breaking them up and moving them around. The fat sees the soap and goes, ah, run away! And it runs away as far as it can in the different dish, and so we get this cool spread out fashion. You guys want to try it again? I've got another dish set up we can do.
Yeah. Yeah.
Yeah.
That's just because the fat parts in the milk are trying to run away from the soap. So whenever you're washing your hands, I want you to think about this explosion of color that you're seeing right here, so that you know what you're doing is getting rid of all of the nasty, dirty virus stuff on your hands by using soap. And if you didn't use soap, it wouldn't go away. Okay? Experiment number 2 has to do with things called acids and bases. Okay? So acids and bases are 2 types of chemicals that you may have heard of acids before. We talk about those a lot in everyday usage. And when we talk about acids, we think about them as really dangerous and problematic. Maybe they're not safe all the time. And that's true when an acid is really strong, but there are some acids that you interact with every day that are really safe. So like orange juice, if you've ever had orange juice or any sort of citrus fruit like a lemon or a lime or a grapefruit, that's that sweet, part of that sweet taste, that edge to the taste that you have in your mouth is because it's acidic. So not all acids are bad. And then on the other end, we have bases. And bases are compounds like, let's see, milk is actually a base, a weak base. And if you've ever cleaned your house with like ammonia, that's a base. And so sometimes we can use acids and bases to do cool things with cooking, or our skin is actually slightly acidic, so that helps protect our skin. Dog hair is slightly acidic, but at a different level of acidity than human skin, so that helps protect dogs from getting sick. And as chemists, sometimes we want to know whether things are acidic or basic. And so we need some way to determine that. And one way we can determine that is if we mix chemicals with something called an indicator. An indicator tells us whether something is acidic or basic. So today I brought, it's going to probably be hard to see, an example of an indicator that does a different color for every level of acidity in the column. And so I thought we would make our own version of this today and see if we can make another rainbow. So I'm going to start with an empty glass tube, okay? And then I'm going to add this red solution. So see how it's starting red? It's red because it's acidic. So I'm going to put a bunch of this in this tube here. And if I just leave it in there, it stays acidic. It's going to all stay red. Can you guys see that okay, or should I move it?
You can see it.
Okay.
Mama?
I'm going to slide it forward a little bit. Then, where's my next solution? I'm going to mix it now with another chemical. The name of this chemical is called sodium carbonate. That's just the name of the chemical. But this chemical is a base. It's the opposite of an acid. So when I mix it in here, what color do you think is going to occur? Do you think it'll stay red, or do you think it'll change to a different color?
It'll stay red.
Okay. We got one vote for staying red. What else do we think could happen? They change colors, right? So I'm going to take this solution and just slowly pour it in here. What we can see maybe is that it's still red at the top, but it's really dark at the bottom. And if we give this a minute, it will start to separate out into different colors and look something like the other one that I showed you to begin with. So we'll start to get a yellow color forming around here, and then it'll turn green, and then blue, and then go all the way down to purple. See if I can change the camera to help a little bit. So you can see it start to separate there, right? You can see that yellow line coming in, and then it gets darker and darker as it goes down. And that's because as those chemicals mix, they do a reaction that is, now we have a mixture of acidic things and basic things. The reason I wanted to share this one with you all today is because sometimes when we clean things around the house, we use acidic cleaning components. And so the one way that we talked about soap to get rid of coronavirus particles on our hands. Another way that we can get rid of them is to clean stuff around us. So you may have seen adults, or you may have helped your parents around the house, like cleaning doorknobs and that sort of thing. One of the really common ways to clean that is with a spray cleaner that uses an acid to break down the virus particles. So now we have two different ways that we've already talked about that we can use chemicals to help keep us safe and clean, as long as we're using them correctly. So I'm going to let this one keep going. We can check on it later. And then we'll go to the one that I'm sort of most excited about. This experiment is nicknamed elephant's toothpaste. So I want to see if you can figure out why we call it elephant's toothpaste, okay? The major chemical, the key ingredient that we're going to use in this one is something called hydrogen peroxide. So sometimes people have this around their house, and they have hydrogen peroxide that is labeled 3% hydrogen peroxide. That means it's a very weak strength of hydrogen peroxide. Because I'm a chemist and I'm trained in how to do this, I have access to a stronger version of hydrogen peroxide. This is 30% hydrogen peroxide, so it's 10 times what you would have access to at your house. So you can try to do this at your house, but it's not going to be maybe as dramatic as what we'll see today, okay? So I'm measuring out a certain amount of hydrogen peroxide to start with. I'm going to pour it into this other piece of glassware. It's called a flask.
I know it's good.
All right. One of the really important features of science is we always have to make observations. So what's going on here?
Nothing really.
Nothing. That's right. Nothing is going on. That is a great observation, right? Well, in reality, something is going on. The hydrogen peroxide in there is breaking down very, very slowly and releasing oxygen, like the oxygen that we breathe. But it's a supercharged version of oxygen, which is why it's a cleaning chemical, because that supercharged version of oxygen can help break up things and clean them. So supercharged oxygen coming out of hydrogen peroxide can help clean up things like virus particles or COVID-19 pieces, okay? So that's how this works as a cleaning agent. But this is, it doesn't look like anything's happening, right? So maybe we can speed it up a little bit. So to do that, I'm going to go back and grab my dish soap again. All right, I've added the dish soap. Now what do we think is happening here? Still nothing, right? It just kind of looks yellow because I put a bunch of yellow dish soap in there. All right, so again, just a yellow liquid in there, right? So I'm going to grab my catalyst. Let's see if we can see what happens. The name of this catalyst is potassium iodide. Again, this is not something you're going to have access to at home. All right, here we go. So can you guys give me a countdown, like 1, 2, 3, before I add my catalyst in?
1,
2,
2, 3.
It's gonna.
Let's see if anything happens this time. All right, so right now, still not much going on. Uh-oh. Oh no, here we go. So we call it elephant's toothpaste because it's about the right same size as toothpaste squeezing out of an elephant's tube of toothpaste. Now this one went a little slow. We can try it again. Let's see if and I can't really show you guys this right now, but it's actually giving off a bunch of heat. I can feel the heat coming off of the tubing, and that's one of the ways, the toothpaste, which is one of the ways that it helps cleans things. All right, this is less dramatic than it should have been. Let's try this one again. All right, so now I've got an empty container we can start with again. See if we can make this a little more dramatic. All right, so again, I'm going to start with my peroxide. And you
Oh
can
my
see that
gosh.
it does make
Crazy.
toothpaste.
It does look like
Lots of teeth,
toothpaste.
lots of really big teeth, so they need lots of toothpaste. So it just
Isn't
keeps
it like
on
really
coming
hot
out.
now?
Or you to clean that up.
I'll have to clean it up.
Yeah, you swim in it. You can swim in it. Like a big pool.
And again,
Yeah.
I can feel heat coming off of this. I don't know if you can see it on the camera, but there's a little bit of steam coming off of it too. The reaction's happening so fast that it's making a bunch of heat.
The blue makes it really look more like toothpaste too.
Mm-hmm.
You can see we've made quite a bit of toothpaste at this point. And if we zoom in here, you can sort of see those bubbles
Zoom.
making and popping on the side, just like how they make supercharged oxygen to help break down things like coronavirus that you may be exposed to. So that's why it's another good cleaner. So we've talked about 3 different kinds of cleaning agents today. 3 different kinds of chemicals that you have probably been around in your everyday life, and they all work differently to help keep us safe. So chemicals aren't necessarily bad, we just have to use them responsibly. And one thing I do want to say that's really, really important is that if you're trying to help somebody clean something up, there's the steam. I don't know if you can see that a little bit better there. If you're trying to help clean something up, you might think, oh, well, if one chemical is good and another chemical is good, if I put them together, then I would make something extra clean. That's not always true. Sometimes that's really unsafe. So we never want to mix cleaning products. We never want to like take bleach that you might use to do laundry or to help clean up something like a toilet and mix it with another type of cleaner. Sometimes a reaction can happen that's really unsafe and can get you in trouble health-wise. And I don't want that to happen to you. So I want you to learn that we should never mix cleaning chemicals unless somebody with special training has told you that it's safe to do, okay?
Does anybody want to say what their favorite one was?
Ooh. I liked the toothpaste. I thought that was really, really cool.
Yeah. Was the best one.
Savvy or Kalia, did you guys have a favorite?
Yeah, the soap one.
The soap one?
Yeah.
Mike, we're so grateful that you did that work to prepare for us and came up with some cool things that are super relevant right now when we think about cleaning and staying safe. So that was just a really cool demonstration.
Right.
Awesome. Okay, it was really great to see you guys and hear your voices.
Nice to see you all.
Bye. Thank you, Mike. That was so much fun.
Bye.